Section 2. Electrical circuits. Upon completion of this section, you will be able to correctly identify and describe the types of electrical circuits used in heavy vehicles, the types of input, output, and control devices. Reading a schematic. A series circuit provides only one path for current to flow. For example, in a simple circuit consisting of 2 light bulbs and a battery, a wire joins the battery to one bulb, to the next bulb, and then back to the battery in one continuous loop, and the bulbs are said to be in series. Section 2. Electrical circuits. However, because there's only one path, you will be able to correctly identify and describe if one of the bulbs is burned out, used in heavy vehicles, current to the other bulb, input, output, and control devices. Series circuits are typically not used in heavy-duty vehicle wiring. A series circuit provides only one path for current to more than one path for current to flow. In a simple circuit consisting of 2 light bulbs and a battery, each wire joins the battery to one battery in loops, to the next bulb, and the bulbs are said to be back to the battery in one continuous loop, and the bulbs are said to be in series. As a result, if one bulb in a parallel circuit is burned out, the rest of the bulbs remain only one path for current to flow in a series through the circuit. If one of the bulbs is burned out, it stops the flow of current to the other bulb, and both bulbs won't light. Series circuits are typically not used in heavy-duty vehicle wiring, and others are in parallel with each other, is called a series parallel circuit. A parallel circuit provides more than one path for current to flow. Using our light bulb example, in a parallel circuit, each bulb is wired separately to the battery in parallel with each other. The bulbs are said to be in parallel. The dimmer control switch controls all of the lamps on the circuit. If one lamp burns out, the others remain lit. One bulb in a parallel circuit is burned out, the rest of the bulbs remain lit, because current can continue to flow through the circuit. An electrical schematic is a map that uses a variety of electrical symbols to identify the individual circuit components and show how in which some of the components are in series and others are in parallel with each other. Is called a series parallel ABS schematics. For example, a lamp from other control switch is mounted in series with a number of lamps that are in parallel with each other. Other circuits are shown on the right side controls all of the lamps on the dashed lines that in one lamp burns out, the others remain lit. Circuits provided by other manufacturers, parallel optional circuits, or the individual components of a circuit. An electrical schematic is a map that uses a variety of electrical devices to identify the individual control device, such as an electronic control unit or ECU. We will refer to both sensors, EOA transmission, magnetic truck ABS types of input devices. A wheel speed sensor on an anti-lock brake system is an example of an input device. Typically shown on the left side of the schematic. Wheel speed data in the form of electrical signals shown on the right side of the schematic, which processes these signals. Dashed lines that enclose sections of a schematic represent circuits provided by other manufacturers. An electronic control unit or ECU or the individual components of a circuit. These devices collect and process data from a variety of input devices provide real-time data to a control device, magnetic as an electronic control unit one or more outputs. To enable output devices, switches, solenoids, motors, are types of input devices. A wheel speed sensor on an anti-lock brake system is an example of an input device. Motors, and warning lights sensors are examples of output devices in the form of electrical signals when the ECU determines that a wheel lock-up condition exists. To monitor wheel speed, the appropriate air modulator valve. An output device to reduce air pressure to the locking unit or ECU is an example of a control device. These devices collect and process data from a variety of devices on the vehicle are all interconnected via bundles of wires and connectors called a wiring harness. Provide one or more wiring harness to enable output devices such as diodes, solenoids, motors, or other electrical components, which will be identified on the wiring schematic. Valves, solenoids, motors, and warning lights. In this section, we will identify the common electrical symbols used in a schematic. ECU determines that a wheel to remember that most electrical circuits activate the appropriate air modulator valve condition, an output which means that current is not flowing air pressure to the locking wheel indicated on the schematic. Input, output, the schematic and control devices on the vehicle are for the electric over-air range bundles of wires and connectors called 9 and 10-speed transmission. A wiring harness may contain devices such as diodes, connectors, or other electrical components. A solid which will be identified on the intersecting wires indicates a connection point in the circuit. Wires that intersect each other will identify the common electrical symbols used in a schematic. It is important to remember that most electrical circuits on a schematic are shown using the series circuit approach, which means that the current is not flowing to locate the battery voltage source indicated on the schematic. If you look at the left side of the schematic, you will see that 12-volt power is supplied through the 12-volt we'll refer to here is for the electric over-air range shift system found in all Meritor vehicle wiring harness transmissions. Note that the ignition circuit is protected with a 10-amp fuse. On the schematic, a solid dot at the junction of two intersecting wires as you move along the positive path of the circuit. Wires that intersect each other without a solid dot at their junction, circuit breakers or diodes are present. Continuing from the switched ignition battery power source schematic using the side of the circuit approach. 12-volt battery voltage is to locate the battery voltage wiring harness. If you look at the left side of the schematic, you will see that 12-volt power is supplied through the 12-volt which is located inside the transmission wiring harness interface connector. In this circuit, the diode prevents any transient wiring spikes from damaging the shift knob. The ignition circuit is protected with a 10-amp fuse. The diode provides positive voltage to pin A as you move along the positive path of the neutral switch. Is a normally safety devices and is shown in the open position or diodes are positioned on the schematic. Continuing from the transmission battery power source along the positive side of the circuit. 12-volt battery voltage enters the transmission wiring harness. Positive voltage continues to pins A and B of connector device is a diode, which is located inside the transmission wiring J2 of the transmission wiring diode prevents any transient voltage spikes from damaging the shift knob circuitry. Travels through the OEM lever harness and into the shift knob. The diode provides positive voltage is identified as the low-range enable circuit. The neutral switch is normally identified as the high-range enable position or in gear position battery voltage. When the key switch transmission is in neutral, the neutral switch is closed. The shift knob circuit has a selector switch for high and low range gear selection of connector J2. The schematic shows the switch from the low range position. Exits connector J2 of the transmission wiring harness through pins A and B. With the low gear range selected, through the OEM lever harness, the shift knob circuit and into the shift knob. Travels through the OEM lever harness identified as the low range enable transmission wiring harness, and pin B is identified as the high range enable circuit. Voltage on both circuits of the transmission wiring harness when the key switch connector is on enables the low gear range solenoid in the transmission. The shift knob circuit has a selector switch for high and low range gear selection. High gear range position. The schematic shows the switch in the low range position, and voltage to pin F is applied. Voltage on pin F of the transmission wiring harness J2 connector enables the high gear range solenoid in the transmission, travels through the OEM lever harness, and re-enters the transmission wiring harness the negative side of the circuit and trace it back to the negative side of the battery. Voltage on pin E, the negative side of the wiring harness is also called the chassis enables the low gear range solenoid. The ground circuit back to the battery exits the shift knob wiring harness on pin D of the shift knob connector. If the selector switch position is changed to the high gear range of the OEM lever harness to pin E and is removed. Pin D of connector J2 on the transmission wiring harness. Voltage on the circuit is connected to transmission wiring harness J2 and low range enables the high gear range solenoid. Finally, the ground circuit exits the transmission wiring harness on pin B of the OEM vehicle harness. Now let's locate the negative side of the circuit and trace it back to the negative side of the battery. The negative side of the circuit is also called the chassis ground circuit. The ground circuit back to the battery exits the shift knob wiring harness on pin D of the shift knob connector. The circuit then enters pin D of the OEM lever harness and pin D of connector J2 on the transmission wiring harness. Here, the circuit is connected to pin B on both the high and low range solenoids. Finally, the ground circuit exits the transmission wiring harness on pin B of the OEM vehicle harness and terminates at the battery negative pin on the OEM interface connector.